Welcome back. We are looking at antiderivatives, and we did this worksheet just to kind of get the idea. And formally stated, a function, if it's x to a power of n, where n is not equal to -1, you get x to the n plus 1 over n plus 1 plus c, where n is not equal to -1. And remember, we did that over here when we were looking at x to the powers, and we found out that you're going to get a 1 over n plus 1, x to the n plus 1 plus c. And I wrote that just sort of as a fraction. I tend to do it as a fraction. So if you have a power, you just add 1 to the power, and that power goes in the denominator, plus c. Now n cannot equal to -1 because you would have 0 in the denominator. So what happens when n is -1? X to the -1, which is 1 over x, and the antiderivative of that is ln of absolute value of x plus c. So we always put this absolute value in, and that has to do with domain. So the domain of this is all real numbers except for 0. Right? It's everything but 0. Now, the domain of log, or natural log, or any log, is that this has to be greater than 0. And in order to have negatives in here, we want a matching domain. And in this case, the domain is x is everything but 0. So you can put in negatives because you absolute value it, and you get a positive, and you can take the natural log. So the reason why they do that is to keep your domains the same. Now, e to the x, got a function, antiderivative itself, plus c. Antiderivative of sine x is negative cosine x plus c. Antiderivative of cosine x is sine x plus c. And you can always go with the derivative of that. Yes is that, and the derivative of that is that. The antiderivative of secant squared x is tangent x plus c. The antiderivative of cosecant squared x is negative cotangent x plus c. The antiderivative of secant x tangent x is secant x plus c, because the derivative of that is that. And the antiderivative of cosecant x cotangent x is negative cosecant x plus c. And now we're getting into these inverse trig functions. Remember sine inverse of x plus c? That the derivative was 1 over the square root of 1 minus x squared. And if this were cosine inverse, it would just be a negative sign. I didn't add that here for some reason. And then here, the antiderivative of 1 over x squared plus 1 is tangent inverse x plus c, because the derivative of that is that. All right, let's do a problem. Looking at the very first problem here, number 1. Is f of x, I'll write it down, equals 1/2 plus 1/3 x plus 1/4 x squared. All right, there's my function. And I am finding the antiderivative. In this section, they're writing a small f as f and capital F as the antiderivative. So whenever you have a constant, that's just going to be 1/2 x, all right, because the derivative of that is that, plus 1/3, and the power on that is x to the 1, so I'm going to add 1, make that 2, and divide by it, plus 1/4, this one becomes x to the add 1, and divide by it. So that's what we're doing with these powers. So if you have a constant, it just gets an x multiplied, because you know the derivative of that is that. And then for this one, I'm using the power rule. The power rule says that if you are taking a power, x to the n power, as long as n is not equal to -1, you just add 1 to it and divide by that same power. So that's what I'm doing. The power is 1. I add 1 to it, I get a 2. So I get x squared over 2 plus, then the 1/4 is just a constant, and then x cubed over 3. Now, to simplify that, I'm still doing capital F of x. This is 1/2 x plus, this is what, 1/6 x squared plus 1/12 x cubed. And you can always check these by taking the derivative. Now, there's one thing that I'm forgetting that we have to always remember, is this plus c. Your antiderivative always has plus some constant. So I'm going to check. Let's take the derivative of what I just did. All right, so the derivative of that is 1/2 plus then 1/6. I take the derivative of that, I get 2x plus 1/12 times the derivative of that is 3x squared plus the derivative of the constant is 0. Let me check. Simplify, I get 1/2 plus 1/3 x plus 1/4 x squared. Let me go check and see if that's what I started with. Yep, that's what I started with. So the answer is this is the antiderivative. All right, I'll be back with number 2.